Hi everyone, my name is Jennifer Rodriguez and I work with CommUniverCity where I am a project coordinator. Happy College Day, yay! I'm a college student at SJSU, as you can tell, and when I graduate, I hope to become a teacher. Maybe one day I'll be teaching you. One of the projects I organize is Engineering in Action, where SJSU engineering students create fun and exciting lessons for students like you and your friends. Many kids from previous years have said that the most fun part is learning that things are happening when we don't even know they're happening. It's almost like magic. Today, we'll meet 3 SGC students who will tell you their superpower. So, watch these 3 lessons about engineering carefully and with curiosity because this is what they are learning, and it may be something you are interested in the future. But first, since we are all learning from home this year, we decided to do something different for College Day because it's about superheroes, and believe it or not, we all have a power we may not know is a power. I'll let Ingen explain.
Hi, my name is Enjin Ao, and I'm a biomedical engineering major at San Jose State University. This is my 3rd year, and I'm learning from home too. But you know what? Hang in there, study hard, have fun, and you'll get to go to college too. So, as you can tell, I'm not from around here. I'm actually from Yangon, Myanmar, Burma, that's in Southeast Asia, and I grew up there. I only moved here like 2 years ago, so it was really recent. I came from a really traditional family, and my grandparents run a clinic downtown, so they're doctors, and yeah, I grew up with them, so that kind of, made me interested in the medical field, and that somehow manifested later in life into my dream to become a biomedical engineer. But they weren't really the driving force behind the reason why I wanted to become a biomedical engineer. So, this might sound relatable to some of you, but it might not. But I grew up watching The Flash too. So, the Flash TV show, on the CW show. So, I grew up watching that and The Arrow. And there's a character on Flash called, Caitlin Snow, Dr. Caitlin Snow. So she's a biomedical engineer, and she just, she's like my role model. She's my superhero. Dr. Caitlin Snow is my superhero. Not only does she like excel in the medical arts, not only can she treat patients, not only can she, do those complicated surgical operations, she also was really technical. She knew how to deal with medical devices. She knew how to work with Cisco, who's another mechanical engineer on the show. So she was working around the lab. She was working in the operations room, and she was proficient with, immunology. She was looking at virus sequences and all those genetic sequences. So it was really interesting. It was mind-blowing to me. The way that she was able to handle all those, diverse subjects, it really, really intrigued me. So yeah, I wanted to become like her. I wanted to pursue biomedical engineering like her. So that was the reason why I chose biomedical engineering to be my major in college, and I'm really happy I stuck with it. Superpower after college is just gonna be like Dr. Caitlin Snow. So I'm planning to I'm planning to specialize in biomechanical engineering, and that's a discipline that deals with biomedical devices, prosthetics, bionic arms, bionic eyes, and so much more, so many more devices that helps improve your lifestyle, and that helps people with disabilities, that helps people with chronic diseases and conditions. So I'm not gonna be your typical superhero. I'm not gonna be your typical superhero who goes out there, saves people falling from buildings, saves people falling from, burning buildings, and, I won't be your typical superhero, but I'll be your superhero who works behind the scenes, who is gonna work on helping you recover from, diseases, injuries, and all those stuff. So yeah, I won't be your typical superhero, but I'll still be saving lives behind the scenes. So yeah, thank you for watching my video. Um, I guess study hard, have fun, and stay in school, and go to college.
That's a lot of options. How fascinating that engineers can work with bionic body parts, and so much more. Here's the first lesson for today. It's about magnetic properties. Remember to put your curiosity hat on.
Hi, I'm Suzanne, and today I'll be talking about magnetic properties and the application of magnets in the engineering field. But first, a little bit about me. I'm a biomedical engineering student at San Jose State, and what that is, it's the application of engineering into the medical field. So a lot of what we do is working on devices or programs to help cure or diagnose people with suffering from various diseases. The reason I really wanted to go to San Jose State is because first, I really love the area that it's in. It's in the heart of Silicon Valley, and then it's surrounded by all these really cool tech companies working on just really awesome devices that you kind of firsthand get to see them roll out and just get to firsthand experience just kind of all the really cool tech that they're working on. But second, I really wanted to go to San Jose State because I wanted to be able to learn different ideas and concepts that I can apply into my own projects that I hope to work on in the future. Why I decided to become an engineer, when I was little, I used to work a lot with my dad in helping him fix cars, or he used to RC race a lot, so I'd help him kind of make some of his cars, and I thought it was really cool, and I'd see him race, and it was really interesting to me. So later in life, when I was in high school, I actually joined a robotics team, and I used to compete with that, and it kind of gave me the remnants of seeing my dad race, and it was really cool. So I really wanted to go become an engineer because I really love doing that, and I love being able to create things and feel like I'm making new products and stuff. And I also really like the medical field too, so that's why I decided to go and pursue biomedical engineering. So if you have any interest in engineering, San Jose State's definitely the best school to be studying at because you're in a really cool location, and the teachers at San Jose State are probably one of the best people you'll ever meet. So moving forward, I want to go and discuss more about magnetic properties and how it applies into engineering, specifically materials engineering. So what materials engineering is, it's the manipulation of different materials properties in order to use them in different projects. And we'll discuss more about that. So what is a magnet? A magnet is a material that produces a magnetic force. And so what that is, it's an invisible force produced by different materials that is able to push or pull various other materials that produce a magnetic force. We've all seen magnets in our refrigerators. So I have a refrigerator magnet here that I pulled from my fridge. It says to conserve water. But this is able to stick onto my fridge because of the magnetic force that it produces in the material that's made out of. So specifically, the material that magnets are made of are metals, but not all metals are magnetic. It takes a really specific type of metal in order that naturally creates that magnetic field. An example of this are iron and nickel, so like nickel coins. But nickel coins are actually 25% pure nickel and 75% copper, I believe. So, but if you were to put a nickel to a magnet, it would actually push or pull the magnet and actually react to that magnetic force. However, just because a metal is magnetic doesn't mean you can't make it magnetic. This doesn't apply for all metals, but an example of a metal that you can make magnetic is steel. I actually have a steel nail right here. So what steel is, it's an alloy of iron and carbon in order to create a really strong metal. So with iron, it's really soft, and I'd be able to bend this if it was made out of iron. However, because it's steel, I'm having a really difficult time to even try to move it a little bit. But that's an example of a metal that I can make magnetic. So exactly how I would make this steel nail into a magnet would be running an electric current through it. So, and this is what I'll be demoing for you guys today. So exactly how I An example of this would actually be if you've seen a junkyard and when they pick up the cars with that big gigantic magnet, that's an electromagnet. So what it's doing, when it's off, it can't pick anything up. But when you turn the electric currency on, it's able to pick things up. And so what it would do, it would go to the car or different material that they would want to move around in the junkyard, and they would turn on the magnet to go and pick up the car or something, and they would move it to where they would want, to the specific location they want to, and they would turn the electricity off in order to drop it. And so that's a good example of what an electromagnet. So moving on to the demo portion of this presentation, I will be making an electromagnet today out of 3 different types of easy to find household appliances, or not appliances, just materials you can find around the house. I do want to forewarn though, you should use this, do this in the presence of a parent or guardian. The magnet does get a little hot when it is touching the wire, so you want your parent or guardian to be handling this when you guys are trying this out on your own, if you are going to. So what you need is a battery, as I showed. This is a 1.5 volt battery, but you can kind of use any type of battery you find. A steel nail that I just kind of found laying around, and a copper wire. I just kind of grabbed this from just some tools that I kind of had laying around. So what you do with this, you're going to get the copper wire, and so what this does, it is a good conductor of electricity, so it helps the electricity flow from the battery and kind of flow through, so when you touch it, it's able to kind of easily allow it to flow through. So what you're going to do, you're going to grab the copper wire and wrap it around the steel nail, and this is creating a coil. And this is going to help when it's touching the battery, it's going to be, the electricity is going to flow through and kind of coil around and help to induce a magnetic force on the steel nail. And that's when it's going to make magnetic. And so, twirl it around the nail. I have a much nicer version right here. So this is what it should look like. You want the 2 tail end pieces because this is what's going to be touching the magnet. So what you're going to do, and this is when your parent or guardian should kind of take over, you're going to have it touch the top part and the bottom part, and now you have an electromagnet. And now you can kind of, if you have anything that's magnetic, you can try it out. So I have this other steel nail right here, and now it's going to attract, and now you have a magnet. So feature Suzanne here. I was watching back my demo that I gave, and I never actually really explained why the 2 steel nails were actually attracted to each other when the electric current was on it. So steel does not have a natural magnetic force. As you can see when I try and attach it, it just drops. However, when I attach this one to the battery, I also apologize, I called the battery a magnet a couple times in there. I hope you guys understood. But, so when this is touching, my little electromagnet is formed, and the 2 nails kind of stick to each other, the reason why it's able to stick is because the electric current is running through this coil, which is allowing it to have a magnetic force. But because this other nail is touching the other nail, this one also kind of has a magnetic force because now some current is also running through this nail as well. So both of these nails have a slight, this nail has a much stronger magnetic force, obviously, compared to this one. But it has enough of a magnetic force to apparently sometimes stick to it. It's usually a little bit better. There you go. But yeah, if you were confused about why the 2 were able to have a magnetic attraction to each other, that's the reason why. So with that explanation, going back to regular scheduled program, Suzanne. If I were to take this out and try to just stick it, it's not going to attract it because there's no electric currency running through it. But if I were to touching there, and it is working again. So that's how you make an electromagnet out of 3 pieces of material that you can find in your home. I hope you guys enjoyed watching the demo. I definitely think it's really interesting and really cool. I remember doing some research and doing just kind of reading about how to go and make this, and a lot of people were saying, oh, I remember doing that when I was in 1st and 2nd grade, and I had never done it, and so doing it when kind of learning about it in college, I still find it very amusing to be able to make an electromagnet at home out of just 3 different easy materials to find. Maybe you guys can find the material around your house and show your parent or guardian how to make an electromagnet, and maybe teach them a little bit about what it is. So out of the presentation, I really hope you guys are able to define what a magnet is, know what types of metals are actually magnetic and what aren't magnetic, and then now you guys know what a electromagnet is. I do kind of want to end the presentation on a fun note. When I was doing research for this, I kind of discovered some new information that I thought was really fun, and I want to share with you guys. So here are 2 things that you didn't know were magnetic. The first one is cereal. Cereal is magnetic. It's not actually the cereal bits that are magnetic, it's what they add into it. So a lot of cereal manufacturers add iron into cereal because consuming iron is actually really good for you. Your blood is able to go and help, iron is able to go and capture oxygen, which is able to go and flow through your system, and so it's actually really good for you to consume iron. So cereal is magnetic because of the iron in it. So if you have a magnet and you have some cereal, maybe you guys can check out to see whether the cereal will stick to your magnet. Another thing that is magnetic that I thought was really interesting is money. So, so the U.S. Prints their dollar bills with magnetic ink, and so this helps to prevent counterfeit money to be used to pay for things. So when they want to check out to see whether they think it's maybe a fake dollar bill, they have various tests. So there's a line test and also a magnetic test. So just some fun things that you guys can maybe check out. You can probably maybe go and find a magnet and see whether it's going to stick to your dollar bill. So those are 2 fun things that maybe you guys didn't know were magnetic before, and now you guys know. You guys can go and share them. I hope you guys had fun watching my presentation on magnetic properties, and I really encourage you guys to maybe do a scavenger hunt around your house, maybe see what is magnetic that you didn't know was before. I really hope you guys are all staying safe, and thank you for watching my presentation. Thank you. Bye.
What you don't see in the video is that the battery got just a bit hot. Engineers have to be careful with their experiments. Let's meet our next superhero in the making. His name is John Diaz, and he's going to take you on a speedy tour through a racing lab. Yay! Hold on tight.
Hi, my name is John and I'm studying mechanical engineering here at San Jose State. I chose engineering because I love cars, machines, and building things with my hands. My dream has always been to build a car that was unique to my own personality. My father, who owns a junkyard, inspired me to do so from a really young age. In college, I have met a lot of amazing people who share similar interests. I love to ride motorcycles, spend time in nature, and work here in the machine shop, and all my friends do the same exact things. So, here in the machine shop, I spend time building a car every single year with my friends. This car right here is the 2020 car that will be racing in 3 months in Arizona. This Baja car was built by us in San Jose State. Everything on this car is built in this machine shop by students. When we're designing the car to be lightweight, strong, and fast, we have to consider materials engineering. The steel that we make these tubes from is important for saving weight and optimizing rigidity. So everything that we have to do relates to materials. We have to choose a material that's going to be strong, that'll be lightweight, and that will conform to the rules and everything that we need to endure. building a car is the welding procedure that you follow. Welding involves using high voltage electricity to fuse metal together on the atomic scale. We use welding to build our frame, the suspension, and the powertrain components. Because welding is such a precision process, we have to be very careful not to alter the mechanical properties of the material. My name is John, and I'm studying mechanical engineering. Working from home is tough, but there's so much to look forward to in college. When I was young, my dream was to build a car, just like this one. And because of this, my superpower is going to be becoming a master welder so I can make my dream come true.
Wow, how cool is it that a college student can build a race car? Now, let me share some top secret information. That racing lab is right here in town at San Jose State University, where I go to school. Imagine yourself here one day, and it could happen. Now, one of my schoolmates, Hannah View, will tell you more about her plans to become a superhero and who she looks like.
Hi, my name is Hannah, and I'm currently an electrical engineering major at San Jose State University. Just like you, I'm learning from home during this pandemic, but I'm sure you are all doing your best, and I'm glad to see that you still want to learn during this time. When I was young, I've always liked to help people and to do what I can to make the world a better place. As an engineer, I could do that by creating devices that help better people's lives. Some examples you use on a daily basis include computers, smartphones, and cars. Each of those were created by engineers like me and have helped to make our lives easier. The device you are using to watch this video right now was made by a team of engineers, and so is the camera I'm using to film. When you look around and think about all the tools you use on a daily basis, you will see that engineers are responsible for most of them. There are a lot of superheroes in real life that are engineers. Throughout history, there have been many men and women that made discoveries to make our lives better and to help students like us learn. One of my superheroes is Katherine Johnson, a mathematician that helped NASA send astronauts to the moon. This was big news at that time since it allowed us to learn more about what is in outer space and space travel. Without her work, we would have never made it onto the moon, and perhaps our current knowledge of space would be limited. When I learned about her as a young girl, it gave me inspiration to study more about math and science. Since there are not many girls in engineering, seeing someone successful like Katherine Johnson encouraged me to study hard and to get where I am today. When I finish college as an engineer, my superpower is going to be making electronic devices to enhance daily life. I want to create a device that you wear to help people with certain health conditions. This will help people figure out if they need to see a doctor by reading specific body signals. I also want to use my knowledge to encourage more students just like you to study math, science, and engineering. I hope by teaching you how exciting this field is, you will want to spend time to learn more.
I really admire how she is thinking about how she can help others with her degree. How will you make the world a better place? Who encourages you? While you think about that, let's check out how 3D printing works. Here are Ahmad, Jack, Matthew, Suhail, and Salman to show us some cool creations. I'll see you on the other side.
Hi everyone, so today we're going to be explaining the process of additive manufacturing.
Hi, my name is Ahmad. My major is biomedical engineering. The reason I decided to go to college is to have a bright future, to gain job security, learn valuable skills, and then make lasting connections. The reason I wanted to become an engineer is because as a kid I used to go to work with my dad, and he would show me all these cool things in the company like robots. I'd be really inspired, and that's the reason I wanted to become an engineer, because my dad led the path for me to be interested and inspired for engineering.
Hi, my name's Jack Highland. My major is mechanical engineering, and I decided to go to college because my parents, friends, and mentors all pushed me to become well educated. I originally wanted to become some sort of medical doctor, but decided to become a mechanical engineer after joining an international winning underwater robotics team. Also for engineers, there's a high employment rate and pretty decent salaries.
Hi, my name is Matthew, and I am a mechanical engineering student at San Jose State. And I decided to become an engineer because from a very young age, I got to watch my dad work as an engineer. And he worked for a lot of cool companies, and he got to work on a lot of cool space programs, such as the Hubble Space Telescope. And that was always really inspiring for me to see as a kid. And he would always come home and tell me about work, or he would take me to work, or we would build things together. We always liked to build models together. Sometimes we'd design stuff to put around the house or in the backyard. And overall, I just always had a really fun time working with my dad and designing and building things. And it made me want to follow a career path that was similar to his own.
Hi everyone, my name is Suhail. I'm a chemical engineer at San Jose State, and I was really inspired by a lot of my family members. I grew up in a family of engineers. Some of them are software engineers, like my father. Some were mechanical engineers or chemical engineers. And one other thing that also inspired me was at a young age, I would always watch Mythbusters, and I love that they always put a lot of science and engineering into all of their projects. Even if they seemed silly, there was always in the background, there was a lot of engineering and science and math going on to make sure that everything was working and that all the projects went to plan.
Hi, my name is Salman. I'm a mechanical engineering student. The reason why I picked mechanical engineering is because my siblings and my father, who are aerospace engineers and mechanical engineers, I always wanted to have work like in the field where I'm always hands-on designing stuff and also understand how things work. In addition, I had a passion to cars, so I always wanted to know how combustion engine works and how they function and how they're designed. So the major that offers all of that was mechanical engineering, because how we study like heat transfer and mechanical energy to thermal energy to electrical energy and all that good stuff.
Additive manufacturing is the process of joining materials together layer by layer to create a 3D object. The materials used can be anything including soft and hard plastics or metals like titanium and gold. The most common form of additive manufacturing is FDM, or just deposition modeling. This is described in detail later.
How it works. Designing a 3D model. First, we start designing a 3D model on a computer software, computer-aided design, also known as CAD programs. So with those programs, we're able to dimension our object and choose the shape and how the looks and also the materials. Most commonly, CAD software by mechanical engineers are SolidWorks and AutoCAD. I personally use SolidWorks because it allows me to run simulations and see how the product looks before I actually upload it to the printer. So once I'm done with the design and I'm ensuring all the dimensions are correct and the shape of the object is going to turn how I want it to be, I upload those files to the 3D printer where it prints the object based on the dimensions picked on the computer. And also the printer is already loaded with a predetermined material that will print the object layer by layer. And this will be explained later by my colleagues. As you can see, we are using a software called SolidWorks, which is commonly used by mechanical engineers. We are modeling a braking disc for a bicycle. As you can see, we are dimensioning everything that we are drawing, which will be later printed on a 3D printer as precise as possible to the dimensions that we determined in the software. Also in this software, we can pick the material of the object that we're drawing, so we can visualize it on the computer before we actually print it, which can save the cost for the manufacturers, and also you can see how it looks before it's actually printed, which is pretty cool.
2 hours later.
So the benefits of additive manufacturing are the ability to create complex designs more efficiently than traditional manufacturing. And that is because additive manufacturing uses, it adds to an object to create it. Whereas standard manufacturing methods, you have an object and you remove material from it to create it. And that's a waste. So this also adds to the ability to design and print a physical object extremely quickly.
3D model overview. 3D modeling is a method of creating an interactive 3D visual representation of an actual object using advanced computer software. Obtaining a visual image of an object is just one advantage. Besides having an exact rendering of the object, 3D modeling gives a lot of technical detail with almost zero errors. Some of the biggest benefits of using 3D modeling is accurate planning, real-world visualization, and speed.
So I'm going to give a quick overview of how the printer itself actually works. If you look at the moving image on the right, you'll see there's a tube at the top leading down to a moving object. And this tube carries the plastic to the moving object, which is really hot. And that hot object melts the plastic, creating a sort of liquid. And this liquid is then used to draw a pattern on the moving platform below it. And as this plastic cools, it hardens and becomes solid. And once these solid patterns are drawn into the shape of the model, they are then built on top of each other until a 3D object is finally created.
So as you can see, this is my 3D printer here. It's called a Creality Ender 3. It's a very affordable Chinese printer that you can buy on Amazon or eBay. And I'm printing in a green PLA, which is a bioplastic made mostly of corn. And as you can see, the printer slowly moves up as it prints each layer, and you slowly see the objects start to emerge. Thanks for watching, everyone. That's our presentation on 3D printing.
Did you know the official name for three-dimensional printing is actually additive manufacturing? I know I learned something new today. We're almost at the end of our time together, but before we start to wrap up, let's hear another story about getting to college and looking to the future. Here's Shay.
Hi, my name is Shay Caver. I'm an electrical engineering student at San Jose State University, and like most of the country right now, I'm actually learning from home too. So keep it up, hang in there, and you'll be able to go to college too one day. So when I was younger, my dream was actually to become an astronaut. And it seemed really cool to have that job, going up into space. But I guess as I got older, I began to realize that there's a lot more that goes into space travel and exploration than just the astronaut. There's a lot of physics and engineering that goes behind all of the components that are responsible for carrying an individual into space. And I found that really interesting. And that also served as a metaphor to my life. when you look around, we have all sorts of technology available to us. And even though we can see what it does on the surface and it's really cool and it works well, there's a lot of design and engineering and thought that goes behind that. And being a consumer of these technologies and these products, I want to understand how they work, and I want to take part in designing them and optimizing them and making them better for the future. So one of the biggest reasons that I wanted to go to college is actually because of my parents. They invested a lot of time and effort into me, and I felt like it would be my way of repaying them to make the most out of it and be successful, do something that I enjoy and do it well. And another big influence for me was actually the hero Iron Man. The thing that fascinated me about him was that he didn't have any supernatural powers. He just used his technology and inventions to put himself in a position where he could fight alongside all these other crazy, talented superheroes just from using his brain. If I could choose a superpower, it actually wouldn't be anything supernatural or out of the ordinary. It would be to use my own intellect and the ability that I have to design something or create something that can help humanity as a whole. So some of my hobbies right now are mountain biking and building computers. And because I really enjoy these things, I want to take it a step further and not only, use them. I don't just want to ride my bike or, use the computer. I actually want to understand how it works and how I can improve it and optimize it, And maybe in the future, I can even add to the industry. I can create something that will be a game changer. And that's why I appreciate studying electrical engineering right now in college. Because I know that in the future I'm going to be able to get a job that I want to. Not only that's going to make me money, but also that I'm passionate about and that I can do for the rest of my life. And another thing is that just being in college and taking these classes, I have the opportunity to do a lot of hands-on things. So not only am I learning concepts in class, I'm actually learning how I can apply them in the real world through projects. I'm learning teamwork and collaboration with other people. And I feel really confident that all these skills are going to prepare me for, the workforce and for later on in life. And so whatever your passions or your hobbies are, keep following your dreams, keep pursuing your interests, study really hard right now so that you can set yourself up for the future. And I hope to see you here one day. Thanks for watching.
I'm glad Shay mentioned investing. Investing is an important part of securing a future when you can take care of yourself and the people you care about. Now, for our final lesson, we present to you something I'm pretty sure you will want to try at home with your parents. It's a little sticky and it stretches. Can you guess what it is? Let's take a look and you'll find out.
Hi kids, welcome to our video about our scientific topic today, which is about polymers. It's real sad that we can't meet you today, so I hope that this video provides like a good substitute. And now we're going to be doing a quick introduction about ourselves.
Hey everyone, my name is Brittany. My major is biomedical engineering. I'm currently finishing up my third year undergrad. I chose to attend college because I enjoy learning and discovering new things. I'm also going to be the first in my family to receive a degree. I chose engineering because in grade school, math and science were my favorite subjects. And I chose specifically biomedical engineering because it allows me to help people that are in need.
Hey everyone, I'm Jericho. I'm also a third year biomedical engineering student. Why did I choose to attend college? Is because I always believe there's room to learn and improve, and college provides more opportunities and connections that would otherwise be unavailable. Why biomedical engineering specifically? I wanted to pursue a career that was medicine-oriented without going through med school, and I want to help deliver on the promise of improving people's quality of life.
Hi everyone, I'm Zachary Akulo. I am also a biomedical engineering student, and I'm also a third year college student as well. I chose to pursue college because I've always wanted to push myself to always want to push my limits in knowledge and everything. I've always wanted to use my skills and knowledge to help others. And what I've always heard from the job recruiters in those big companies like Apple or Dell or PlayStation or whatever, that they always love to hire people who are willing to push themselves to learn new things and always willing to grow. Now, why I chose to become a biomedical engineer? Well, it started out that my mom is a nurse and my dad is a retired U.S. Air Force. And I wanted to choose my own career where I still get to help people just like my parents did. And since math and science were my strengths in high school, this major brought the best of both worlds.
Hi, my name is Kimberly, and I am a third-year industrial and systems engineering student. So why did I want to go to college? So one of my reasoning is because I wanted to continue learning. I always loved learning, and also to gain new experience in the college atmosphere. So why did I choose engineering specifically? So initially, my dream career as a kid was to be a dentist. But the downside of being a dentist is that you had to really have strong will to stand blood, and I couldn't really stand blood, so that my dream just died there. So also in high school, my second career that I thought that I could pursue was engineering, which I end up pursuing now. So the positives of being an engineer is that there's a lot of career options, and there's a lot of hands-on activity, which I really enjoy. And there's also designing and being able to do things like on products.
Hey guys, my name is Beze Azar, and I'm a fourth-year biomedical engineering student. I went to college because I've always been very inspired to study science, and this branch that I like the most is chemistry. And I also enjoy being in the academic environment. I decided to study engineering because I always wanted to be a scientist, but I also wanted to be hands-on, and engineering seemed like a perfect mixture of that, especially biomedical engineering. And everyone in my family, they were already engineers, so for me, it just seemed like I was destined to become an engineer one day as well.
So what are polymers? Everything in this picture you see right here is a type of polymer. And in the next slide, we're going to go ahead and go into details to the technical definition of polymers. So what is a polymer? A polymer is a chain of repeating units, and these units are called monomers. As you can see in the diagram to the right, it starts off with single units, and then they turn into a forming line. The monomer itself is a molecule that can react with other identical molecules to form these polymers. And in the next slide, we're going to talk about polymerization.
So what is polymerization? So the definition is that it's a process which monomers chemically react with other identical monomers to form polymers. So as you can see in the diagram on the right side, so there are like these bead-like monomers, and then the reaction, which is polymerization, becomes a polymer.
To better understand and visualize polymers, we can look at Legos. So in this image, you can consider the square Legos as monomers and the polymers as a square Legos connected to one another. So if you look at the Legos, the things that are on the top of the Legos are called studs, which are very similar to the bonds between those monomers. In chemistry, this type of bond is called a covalent bond. And a covalent bond is a chemical bond that involves the sharing of electron pairs between atoms.
So the two main types of polymers can be designated as thermoplastics or thermosetting polymers. Thermoplastics soften when heated and harden when cooled, and are reversible and sometimes repeated. An example of which would be plastic water bottles.
Thermosetting polymers are permanently hard during their formation and do not soften upon heating. An example of which would be polyester resin, which is found in car body parts.
Yes. Before trying out any experiments in this video, be sure to have your parent or guardian help you. Antes de probar cualquier experimento en este video, asegúrate de que un padre o guardián te ayuden.
And now we'll be heading into a quick video that basically provides a visualization of the polymers itself.
Hi everyone, I am Zachary Arculo of the Polymer Group, and today I will be providing a quick demo on polymers. As you can see in front of me, there are two small buckets. One of them is a small bucket of water, and the other one is a small bucket of slime. As you can see in the small bucket of water, it's very loose and sloshy, that if I even shake it in a certain direction, like I shake it clockwise, the motion of the water will move clockwise in accordance with how I swirl in the first place. Now, as you can see in this bucket of slime, it's not exactly solid as a rock, but it's not exactly loose as a liquid either, because if the slime was as loose as a liquid, it would simply break out of my hands and spill into the desk itself. Now, as you can see here, this slime can stretch, but it has a limit to how it can stretch before it breaks from each other. Now, how exactly is slime different from water? As you can see in this paper I provided here, this is basically the chemistry of both water and slime. As you can see in the left side of water, the chemical structure is H2O, and this here is a visualization of H2O itself. The two hydrogens are bonded to the one oxygen. Now, as you can see down below, it may seem a little complicated, but this is just simply how of multiple water molecules binded to one another. Now, moving on to the chemistry of the slime. This monstrosity of a chemical structure of slime, you don't need to worry about it. Just focus on where I drew the red lines here. What I circled with these red lines is the chain of carbon. As you can see here, this is a carbon bonded to a carbon, bonded to a carbon, bonded to a carbon, bonded to a carbon. And this is basically just the mirrored version of this, carbon, 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 carbon. Or as you can see back down here, it's basically just a visual representation of what I just said just a few seconds ago, of many carbon molecules bounded together. Because these identical carbon molecules are bonded to one another, this is what is called a polymer, because a polymer is a chain of monomers bonded together. The monomer is a carbon. It's carbon in this case, because it's carbon bonded to carbon, bonded to carbon, and so forth. And why exactly is water not a polymer? Well, as you can see, what I circled in the red here is basically a chain, but it's not exactly an identical chain though. As you can see here, it's hydrogen bonded to oxygen, bonded to hydrogen, bonded to oxygen, bonded to hydrogen, oxygen, hydrogen. And this is basically what I just said just a couple of seconds ago. Hydrogen, oxygen, hydrogen, oxygen, hydrogen, oxygen, and hydrogen. Now sure, you do see a pattern as it switches off between hydrogen and oxygen, but it's not a polymer because this chain here has two monomers. If it was only just one monomer, like for example hydrogen, and it's like hydrogen, 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 then it would be a polymer. But in this case here, it's not a polymer because there are two monomers instead of one. Now you will learn more about this in the future years of science, but this is basically just a quick demonstration of polymers. I hope this is helpful.
All right, and that concludes the video about polymers. I hope that video has been proven helpful to you kids. Now, if you kids remember, there was supposed to be an actual hands-on activity, which for our group, we're going to have you kids actually make slime itself. But because of the evil COVID-19, we are now confined to our houses. So I hope that small video provided some proven to be educational for you kids. Now here is the worksheet that we will give you kids to work on your own and compete with one another. As you can see, there are two columns of words. The left side is the instructions, and the right side is a long list of polymers. You kids can read it on your own time, but I'll go over the instructions real quick. Now, as you can see in the instructions, the first step is that you have to look at this list of polymers and see if you have those polymers at your home. And as you can see, this worksheet is safe to play at home and such. It's little scavenger hunts. Now we have made this list of polymers to be pretty big because we want you kids to work with many options on the table. Now the second step is to gather all the polymers at a certain spot in your house. Then take a photo with it as actual evidence that you actually have them, that you're not just cheating or making it up. And count the polymers from your list. Like for example, if I have 20 fizzy drink bottles, three detergent bottles, and 2 margarine tubs, then my number would be 25. And I hope that example makes sense. Then once you get your number, you kids will have to compare with your classmates on how many polymers you kids got. And the highest number wins. And that concludes the worksheet of our little presentation. And that concludes the actual presentation itself. I hope you kids learned something about polymers, and it is a shame that we could not meet you all in person. I hope this has been helpful. Have a great day, and stay safe. Bye-bye.
Welcome back. Brittany, Jericho, Zachary, Faiza, and Kimberly made that look really fun. I think I'll try it later. But first, I want to thank you all for learning with us today and meeting some new college friends. Remember that there is always a helping hand if you ask, and that there is always more than one path to achieve your goals. Dire gives us a great example. Let's take a look.
Hi, my name is Dire Ibrahim, and I'm an industrial and systems engineering major at San Jose State University. And just like you, we're learning from home. Hang in there, and you can go to college too. When I was young, my dream was to help people. Helping people was rather vague, so I soon realized that I needed to narrow that down and think of how that aligned with my interests and hobbies to get an idea on what I should do moving forward. I always enjoyed mathematics as a child and building things with the materials I had around me, so I thought engineering might be a good fit. I was encouraged to go to college by my family, who didn't have the same opportunities that I had in this country. After immigrating from corruption and war in northeastern Africa, like most people, they've come to the United States to try and provide a better life for themselves and their families. Knowing that has inspired me to continue working hard and not take anything for granted. I chose industrial engineering at San Jose State University because I not only enjoy the math and sciences that I've learned, but the technical aspect of applying my knowledge towards service systems and manufacturing problems. In 2020, service industries now make up a significant portion of the economic GDP in the United States and other Western developed post-industrial societies and countries. Thus, maintaining and improving it will be a huge engineering challenge, and being able to contribute and make a difference on those significant challenges to make life easier for people will mean a lot to me personally. At San Jose State, some of my favorite on-campus locations to go to is the MLK Library, the Student Union, the Spartan Recreation Center, and the Engineering Building, all of which I attend to either study or relax in between studies and classes. If you decide to attend SJSU, I encourage you to take advantage of the many great programs available to help support students. I had the opportunity to join the EOP and MEP programs, which both stand for the Educational Opportunity Program and Mesa Engineering Program respectively. Both programs assist communities of first generation or low income students that come from different ethnic and cultural backgrounds eager to attain a college education. They provide services such as a study lounge, internship and job leads, academic counseling, and in some cases financial support. My superhero in life is basketball star Kobe Bryant and boxer Muhammad Ali. I just love their work ethic and the fact that they didn't cheat themselves and worked extremely hard to be great in their respective careers that they committed themselves towards. That mentality of hard work and commitment to be great can be applicable not only in academia but in life after college. Because of college, my superpower is going to be to inspire other people, a new generation of students by telling my story, assist my community, and helping resolve management-based problems or management-based organizational problems utilizing my industrial engineering toolkit. Thank you for your time.
Let's recap. Today we learned about magnetic properties and that batteries can get hot. We learned about building race cars in college, and we learned that plastics are polymers and can make slime. We also met some new friends who were kind enough to share their stories because they want you to succeed and they know you can do it. If you also believe you can succeed and you enjoyed this video, make sure you like it by giving us a thumbs up. Remember to be brave and curious about new things. I can't wait to see what kind of superhero you become and the power you will develop. Enjoy the rest of college week and visit us at our website at cucsj.org. There's a lot to see. Bye everyone!